See, why is it not doing? Oh, come on.
Oh, it's right here.
Oh, there we go. Okay, pyrotechnic devices perform very useful functions. They can detonate or destroy and break things up. They can generate flames to do engine ignition. They can be smoke generators to do visual tracking. They can supply pressure pulses to do actuation. So you can have pyro valves, release mechanisms, pin pullers, cable cutters, stage separation devices. They can also be gas generators for deploying payload, parachutes, deploying fins, deploying air brakes. You can make up a fire extinguisher with a pyrotechnic device. They do that on airplanes. And you can pressurize, do pressurization if you have room temperature propellants. How the pyrotechnic devices work, a lot of times you'll have something that's like an electric match. So that supplies the ignition. Then you have to have a booster charge, because usually the match isn't strong enough to light off whatever's going to do your pyrotechnic charge. And so you have a intermediate charge that you're setting up. So the diagram that I'm showing here is actually a airbag deployment device. And you see in the middle, there's the igniter. And then there's up on the top, it says, if you can't read it, it's ignition intensifier. That's a booster charge. And then there's propellant pellets. And so the airbag charge is actually to generate gas, a lot of gas in a very short time, so that it can deploy an airbag so that when you're in an accident, you don't hit the steering column. So each one of the things, each one of the pyrotechnic pieces has a different kind of chemistry to it. But the pyrotechnic charge itself does either a detonation, generates gas or flame or smoke. Usually what happens is the electric match is fairly slow burning, and you need something that catches real easy on fire. That would be the booster charge, but it doesn't have the big bang that you need it to. So that's why you do at least 3 pieces. When I do my igniters that we use for our liquid engines, usually I use an electric match to start it, and I use black powder mixed with magnesium grains coated on top of a piece of ammonium perchlorate based rocket propellant, because an electric match doesn't normally start the rocket propellant just by touching the match to it. So you can have injury or death when you're working with pyrotechnic devices in very close proximity if they inadvertently ignite. They have intense flames causing burns, smoke causing lung irritation and poisoning. The ammonium perchlorate, the APCP propellant I use, has it puts hydrochloric acid gas out. So that's one reason why we always keep you far away even from the solid propellant rockets. We let that dissipate. But if you're standing right next to it, you're going to get a full lungful of it. You can get blast waves causing trauma, and you can also get shrapnel causing penetration. And the trauma and the penetration is probably the leading cause of what would kill you. Okay, what you want to do with these devices is avoid inadvertent initiation. So causes of initiation would be static discharge, radio frequency, stray currents or voltage. You could have mechanical impact, penetration, crush, damage, or cutting. So all those can happen while you're assembling your rocket. Also sparks, heat, fire, friction, chemical reactions, and even age can cause things to be sensitive and inadvertently ignite. And I have heard of people loading their deployment charge on their rocket, and they have the electric match all hooked up, and they're walking out to the pad to place it, and the thing goes off inadvertently. And that was part of static electric charge. I've also had it where I've gone and armed the recovery system, and the recovery system immediately goes off, which is not. That meant that there was straight current in the recovery electronics that set off the match. Handling precautions. You want to prevent any cuts, drops, crushing, or damage to your pyrotechnics. Short the igniter leads together. What that does is it reduces your sensitivity to static discharge and radio frequencies. You should have no smoking, sparks, or flame within 50 feet of wherever you're working on the charges. You want to eliminate stray currents or voltages. I recommend that you disconnect your battery to your recovery electronics before you hook up your electronics. Also, I think that you should make it so that you can arm your recovery electronics from the bottom of the rocket once it's on the launch rail. So if you arm it and the recovery system is not working right and it deploys it, you're not directly in the blast. I was arming a recovery system. I just put it all together up on the launch rail. I was in a basket hanging from the side of the launch rail. I went to arm, and the thing initiated blowing the nose cone off. It bounced off my arm and then proceeded to hit somebody on the ground on their shoulder. So pyrotechnics can be touchy, and they can also injure you. If I was startled, I could have fallen, with bad result. Okay, precautions while working with pyrotechnics. Use undamaged pyrotechnic devices. You do not want any damage to show up on those crushing or cutting or any of that stuff. Avoid carrying igniters or pyrotechnic devices in your pocket. As a matter of fact, I'd even recommend that you don't carry batteries. Our old president of the Friends Amateur Rocketry had been working with a camera. He put some spare AAA batteries in his pocket, and he had a bunch of change in there. All of a sudden, we see him doing the fire dance, trying to put out what was going on in his pocket. He pulled it out, and it shorted out his battery in his pocket, and it overheated and was burning him. Keep your work area clean and free of clutter. Keep non-essential people clear of your workspace. A lot of times I see students working on stuff, and it's just like a huge crowd of people. And there's one guy amongst them all that's working on their recovery electronics or their igniter. You really need to separate that guy away from everybody, because if it goes off, even just people trying to evacuate the area could get injured. Let's see. So avoid devices that show the signs of corrosion. A lot of times what will happen is you'll make up some kind of igniter or an ignition charge. And let's say you had it for one launch, and now it's 2 years later and you want to use it again. If it shows corrosion, or let's say the chemical is supposed to be powdery and now it's all caking, I'd say don't use it. You're asking for trouble. And that goes with the next one, chemical separation and discoloration. I would say even clumping and things like that would be a sign that you shouldn't use it. Also, you want to transport in a rigid container to try to prevent damage and crushing, and also the rigid container will protect you if the device lights off. So you want to make sure it's substantial enough that you can't have your igniter, let's say, burn through the box, because that would be a really bad deal if you're driving in a car and you got this in the crew cabin and all of a sudden it's starting to belch out flames. Could be pretty scary. And then the other thing would be is destroy all old or damaged pyrotechnic devices. It's not good to just hang on to them forever. You should probably destroy them if you're not going to use them. Okay, pyrotechnic devices in general are controlled by the Bureau of Alcohol, Tobacco, and Firearms and Explosives. You never hear them say it, but the BATFE. I actually left off the B. But they're responsible for explosives. So if you're at the rocket site and you actually blow yourself up or people get injured because of an explosion due to your pyrotechnic device, guess who's going to be there investigating? It's going to be the ATFE. But they have a requirement that says that you need to have at least a low explosives user permit. Oh, question?
Yes, there's different categories of explosives magazines. Which
I think there's a bunch of different kinds. So there's an indoor magazine, there's an outdoor magazine. But if you're using low explosives, there's one or two kinds. I forget whether it's like a class 3 and class 4. But I have a whole range of different magazines out at our rocket site. 2 of the magazines can use high explosives. We have a cargo container that's set up to do all low explosives, 1.3C. And then we have 3 concrete magazines that we got surplus from the military. They could be used as high explosives, but we have them set up for low explosives. As a matter of fact, right now we're in the middle, next week, the Kern County Fire Department's coming out to inspect our magazines to give us the Kern County fire department permit for them. And we have the Bureau of Alcohol, Tobacco, and Firearms is coming out the next day to inspect because our explosives permit with the feds is going to expire shortly. And we had signed up to because we have a high explosives magazine, we signed up to be a high explosives manufacturer. So having an explosive permit is not the only thing you have to have. You do have to have a magazine that goes with it. And in general, you need to have a permit through the local fire department. And that magazine is actually a 2-way protection. One is it keeps a pyrotechnic material that you're using from being damaged or being stolen or catching on fire. And it's also protecting the people on the outside. And then they'll have rules that say that the magazine has to be 50 feet away from any inhabited structure. So it's really tough to have an explosive magazine at your house. A lot of times you need several acres for your property so that you can have that, and one of our guys has that. What we do usually is we have the explosive magazine out at FAR, and we give people with the LEUP, the low explosives user permit contingency storage, out at our site. So the LEUP allows you also to transport your, use it and transport your pyrotechnics. And if you want more information about getting the explosive permit, you go to the ATF website, which I included on the charts here. So my recommendation to you guys is, I like stuff that explodes, but it adds extra complexity to your rocket. And I would advise you to minimize or avoid using pyrotechnics if at all possible. Because what that does is it will restrict how you work on your rocket. And once you have pyrotechnic devices in your rocket, you really need to clear the area around your rocket. Because if you got a nose cone that's packed with a parachute and it's got a recovery charge, now everybody that's in front of that nose cone is at risk of being hit if somebody sets off the recovery charge. You have a question? You have a question? Okay. So that's my recommendation. Try to minimize it. And what I have done over time, and I've worked with Cal State Long Beach, is I actually came up with a spring-loaded recovery system, and the only pyrotechnic device in that system was 2 pin pullers that were a little bit of gunpowder and a electric match. So the pin puller pulls and it releases the nose cone and flips it off using springs. And then we had one more pin puller that So you deploy the drogue, and then you have another pin puller that pulls, and it releases the drogue that pulls out the main chute. Every time I've tried to use a pyro charge to actually push a parachute out, I've burned the parachute. Whether I used a bag for it or I didn't use a bag, it always seems to creep through and melt some part of my parachute. Now, keep in mind, I'm not using ballistic nylon. These rockets are really big, so we're using man-rated parachutes, which are silk parachutes, and the silk burns really easy. So, a prohibition through the contest is that you are not allowed to use, or it's actually prohibited using 1.1 explosives. So what that is anything that's like RDX or any kind of high energy explosive device. So they use that even in cable cutters for cutting parachutes. And also you could use it as a linear shaped charge to separate your rocket. We are not allowing to use that. That's beyond the scope of this competition. And it really needs to have, you need to have a professional do it. Question back there?
Where will we find the definition of the 1.1 explosives?
Look on Wikipedia.
It's not like under a specific organization?
Correct.
Okay.
1.1 basically is dynamite, C4. There is a 1.2. I had it listed on here, but the thing is that you wouldn't be using 1.2. So when you see them do mining, they'll usually drill a hole in the ground. They fill it up with ammonium nitrate, and then they put dynamite in it. Well, the ammonium nitrate down the hole is really the 1.2. It's a mass detonatable mixture. You wouldn't use that on a rocket. But the 1.1, and there's different kinds. So the APCP propellant that we use for the solid rockets, you can call it 1.3C, or they do call it 1.4. And there's fireworks that is I think 1.3G, but we don't even do fireworks. So, okay.
Bernard and Tripoli go to court to prove that that was not an explosive?
Yeah, they went, see, ATF says that they cover 1.1, 1.2, and 1.3. And Tripoli went to court and got them the judge that ATF doesn't control the motors. But there's a problem with that is that if you have a motor that you've made or a pyrotechnic device that you made, it does not have a particular classification. And what most establishments want you to do is take your pyro device, you send it to a lab, they give you what the rating is, and then you can get your EX license for shipping it through the mail, or you can get it for transporting. Well, until it gets that classification, there's only one thing you can do with your pyrotechnic devices: send it to the testing lab. So, and if you don't know what it is, then the ATF controls it. See, if you made your own APCP propellant, they don't know what it is. They don't know if it'll blow up. And most manufacturers, what they do is they'll make the propellant, they'll have it evaluated, and then they get an EX permit for shipping it. And it's usually a fairly expensive proposition. And that's it. How'd I do? Oh, got another 10 minutes. Any other questions? How about you guys online? I know Canada has a lot of the same regulations. Okay. Well, we'll take a 10-minute break, I think, until we get to the next subject.